Good morning, one and all. So we are starting the second lecture of control systems. Today we are going to start with the syllabus. So previous lecture was all about the introduction. We had discussed the syllabus. We had discussed the book. That is, we are going to follow the book of M. Gopal. Soft copy of that book is already given to you. Now today we are going to see the basic control system configurations. So though I have mentioned the topics, you will find that this is the first three topics in your syllabus or module number 1, that is called as introduction to control systems. So there are a lot of theory you will find in book, what is called as loop, branch and system and all other things. So those are very basic definitions. I'm not going into it. I'll directly be entering of our control system. I'll be starting with what is meant by open loop, closed loop, what is meant by feedback control, feed forward control, and what is analog and digital control. So intentionally I will not do the digital control part today. But the first 5 types, that is open loop, closed loop, feed forward, feedback, and analog control. So these 5 things we will do today. I will tell you what is the digital control, how is it different from analog control, and we'll see the digital block diagram, digital control block diagram next. So I'm starting with what is called as open loop and closed loop control system. We are going to discuss 2 industrial processes. So first industrial process is a very simple. We are filling up a bucket. So more than industrial process, this is a domestic process that we are finding. We are going to fill a bucket. So this bucket is going to be filled up with the water. Now there is something called as process variable. So Q means flow. And there is a control valve. Now this control valve can be manual. This control valve can be electronic. Now there is a tap. Through the tap water is coming and water is pouring inside the bucket, and bucket is getting filled up. Okay, so QA is nothing but the flow or volume of water. So later on we'll be using a lot of definitions and maybe some equation modeling. At the time this QA will come into picture. At present you should not worry about what is QA. Okay, so a very simple process, that is there is a tap and the tap is giving water inside the bucket, and bucket is getting filled up, and there is a control valve. Okay, and it is kind of a manual control that we have to go there and we have to close the tap or open the tap to fill up or stop the bucket filling up. Okay, now what is the problem in this? So this is an open loop control system because there is no feedback, because there is no sensor. It's a very simple process. We all have bucket at our home. We fill the water before we take bath. So we just go in the bathroom, we open the tap. So that's a manually controlled tap. That is not auto tap. That's a manually controlled tap, and it fills the bucket with the water. This is the best example of a open loop process. So in exam also we can ask you explain an open loop process. In that case you can explain this. Or if you want to give an industrial touch, you can say it's a very big container. It is getting filled up with some kind of fluid or liquid, industrial liquid, and there is an inlet. Okay, you cannot call tap at that time, you have to call inlet. So inlet is pouring water or liquid inside the very big container, industrial container, and there is no control on the control valve. So it's an open loop process. What is the downside? So open loop control process or open loop process is having only one advantage. That is, it is very simple and it is less costly. So these are the advantages. So one example is asked generally, what is the difference between open loop control and closed loop control. So for that you have to prepare a comparison. So in that comparison, only positive point that you can talk about open loop control is it is very simple, it is not costly. Okay, and operating of open loop control is very simple, but that does not solve our process because open loop control is against automation, as it is shown toward the below of the slide. So what is the problem in this open loop control? When the bucket is filled, okay, then also the water will keep on filling the bucket if we are not around. So that is the biggest problem. We just many times it happens, we just open the tap and we go some other place, and when we come back we find that there is overflow in the bucket. So though the bucket is filled, but then also the tap cannot understand that because it's a manual tap, manual control. So without our intervention there will be wastage of water. So that is given in the last line. That is wastage of water resource. This is a very important resource in our absence. And the whole process goes against automation. So this is not a so, but in nowadays everywhere the main word is automation. So we have to design the same process, the same tap, but it should be controlled by some electronic controller. So the main difference is, so here in the left side I have written figure 1 as open loop process by red. So in my whole slides, whenever there is a red, means it's bad. So it's having some danger. And whenever it is green, so this is the convention I'm going to follow. Whenever it is green means it is something better. Okay. And this is something better than the red process. So reds are given for generally bad thing, generally. Okay, sometimes it is used for highlighting. And greens are generally given for good things. So closed loop control is better than open loop control. Why? Because here how we are making the open loop control into closed loop control. Here the same process is there. Only difference you will find that we have put a water level sensor. Okay, so there are many types of water level sensor, resistive type, capacitive type. Okay, many types. We can put semiconductor type water level sensor. So in the 6th semester, there is a subject called as sensors and transducer. There you will study what are the different types of water level sensor. So we can fit the water level sensor up, down, wherever we want. We can put it down here somewhere. What is the level of water we want? So in water tank at the top of our terrace, we put sometimes sensor in the tank. That is, if the water is filled up to this much point inside the tank, it will give a signal and the tap will automatically close. Tap will automatically close means it is not going to give any water. So the same thing we are implementing here. So for that, there should be some electronics here. So in the left side, open loop control, there is no electronics. It's a very simple mechanical process. In the right side, if you are putting a water level sensor, this sensor requires some kind of supply. And then there will go a feedback. Okay, so what is meant by feedback? Feedback is nothing but a signal which will go from the sensor to the tap control valve. Now this tap control valve here, it is not a simple manual thing. It's a electronic thing. So between this sensor and between this control valve, there is something which is called as an actuator. Okay, so signal actually motivates or mobilizes the actuator. Actuator is kind of a solenoid valve or something. What is the principle? If electricity flows through that solenoid valve, at that time there will happen some movement, and that movement will open or close the valve. This much you know at this point. So as soon as the water was below, initially the tap is giving water, water level is increasing, and water level hits the water level sensor. Because I have kept the water level sensor at this height. As soon as the water hits this water level sensor, this sensor generates a signal. This signal goes to the automatic tap control valve. So between the sensor and the tap control valve, there is an actuator. Actuator is nothing but a signal to mechanical movement conversion device that will control the valve, that will close the valve, and there will be no water flow inside this. So this water flow will be cut. That means tap band ho jayega. As soon as the water level sensor gives the signal to the tap, tap will get closed, band. Okay, there will be no water flowing through the liquid. So what will happen is, final result is the water level will rise to this point and it will stay there. So what is the advantage, or what are we actually achieving? What we are achieving is solution. So whatever given in the left side is without automation, whatever given in the left side requires human intervention, but whatever is there in the right side, closed loop process here, when the water level is high, that means up to a pre-decided level, then the signal from the sensor will close the control valve and the water inlet will stop without any human intervention. So these words are very important: without any human intervention. In the previous case, it could save the wastage of water, but human intervention was required. You have made the valve open, water is pouring in, and you have to stand there to check bucket bhara kya. If the bucket is getting filled up, then you have to close the tap. But in the right side, without any human intervention, you just have to excuse me, you just have to put the sensor, you have to close this loop, and you go any place you want. As soon as the sensor is hit, It will generate the control signal, it will give the signal to the tap, and tap will get closed automatically and the water supply cease. Okay, so in this case, second case, this word without human intervention is very important. That means closed loop process is helping automation, whereas the open loop process is against automation. Closed loop process is generating a feedback path. So I'm telling you the difference. Okay, closed loop process is generating a feedback path. So there is a feedback loop. Okay, open loop process, there is no feedback. So open loop process does not know that the bucket is filled. And there is one word in the control system which says that the process runs away. What is meant by process runs away? In the open loop control, you find that water is overflowing and process is running away. Okay, because the process is going beyond your control. You are wasting a lot of water. That is actually what happens with open loop process. So open loop process runs away many times. So there is a big possibility that open loop process will runs away. Run away means it is beyond your control. But closed loop process can never run away, because we are setting the level of the water level sensor or liquid level sensor, and the process can never run away. As soon as the water is filled up till water level sensor, the process will stop. So there is not a single moment when the process is not in our control. So process is always in our control. So this is the advantage of feedback. And the biggest important difference between open loop and closed loop control is the signal feedback which assists automation. So what is meant by automation? Without human intervention also, the process should not run away. The process should always be in our control, whether I'm standing there or I'm not standing there. Okay, so what is the result, net result in this case? We are not wasting any water. So with this very small change, that is a simple sensor and a feedback signal, so wire, sensor and a small power supply, we can automatize the whole process. We are saving a lot of water. So this is the difference between open loop process and closed loop process. So this closed loop process is called as feedback process. Same as teaching, whatever we teach at the end of the semester, we ask for your feedback. Why do we want feedback from you? That whatever mistakes I have made in this semester as a teacher, we ask student that you just tell me what all good things I have done and what all bad things I have done. Whatever good things I have done, it's okay. Okay, that will give me praise and all fine. But whatever bad things I have done, that is the something which is going to tell me that next time you have to improve upon this process. So feedback control is something where always we are working for the betterment of the system in the next stage. But open loop process, there is no betterment possible, because the process runs away, because the process is not in our control always. But closed loop process always in our control. Okay, it is a little costly. That is the downside, because we have to connect a sensor, we have to connect some electronics, we have to connect the actuator here, because the signal cannot directly control the valve. Okay, signal is a very small electronic signal, maybe 10 milliampere or 100 milliampere or something. Okay, that is produced at the by the sensor. So between sensor and the actual element, that is tap, there should be an actuator. So actuator converts the electronic signal into mechanical signal. So in many books, that very small thing actuator is not shown. If voice is breaking, I'm sorry, it is due to network issue. Uh, this thing will be uploaded and you will find it proper. So don't worry. Okay, the lecture will be uploaded, link will be given. So it's due to network issue, can't help. Uh, if you have any doubt, you can ask, or just see the slides. Slides will be self-explanatory. So please keep on checking the slides. Thank you. So this is what is the difference between open loop process and closed loop process. So closed loop process is adding to the automation. Closed loop process is improving. So there is scope of improvement for closed loop process. Closed loop process is little more costly because we have to connect some extra elements there. But process never runs away. Process is always in our control. Next, we are going to see an industrial process number 2. Okay, so this is also industrial process. I would like you to see here. The process we will understand first. So this is a water bath, and water inlet is coming from the top. So there is a cold water inlet, and we want hot water at the output. This is the main agenda. So cold water is being put. QA is the volume of the water. A is the cross section of this tap or pipe which is there at the top, and we are getting hot water at the output. So how we are making the cold water hot? By steam inlet. So there is a pipe inserted in the water bath. So this thing is not called bucket. The whole thing water container is called as water bath. So inside this water bath, there is a steam flow. Okay. So this steam flow is by some metallic pipe. So whenever the steam flows through the water, the metallic pipe actually gives out the heat taken from the steam into the water. So directly steam we cannot put into water, but steam pipe, metallic pipe we can put into water. So if you go abroad, you will be finding that inside room also, as a room heater, they are using steam. Okay, because abroad it is very cold, -10, -20 degrees centigrade, a lot of places. So there inside room they are keeping this steam pipe, and those pipes are metallic pipe. So those temperature inside the room. So the same thing is happening in the water. So this is a steam pipe, and this is a valve. Okay, so this valve, by controlling this valve, we can control the inlet of steam inside the pipe. It's a metallic pipe. So whenever we are opening this valve, at the time steam is entering this pipe, and at the time this water inside this container is getting heated up, and it may be a running process. Okay, a running process means cold water inlet is open, chalu hai, and hot water outlet is also on. So continuously the cold water is coming inside, getting heated up, and hot water is going out. So this is called as running process. Second process is we are closing this hot water outlet for some time. We are allowing the water to come in, get heated up, and when, so there is a temperature sensor here. Whenever the predetermined temperature is reached, at that time only we are opening the outlet and we are getting heated water. So that is not a running process. Running process means continuously water is coming in, getting heated up, and hot water is coming out. So in that case, steam flow will be continuously running, water flow inlet will be continuously running, water flow outlet will be continuously running. But in this case, you find that we don't have any control over steam. We are not able to control this steam control valve. Sometimes if it happens that very hot water is coming, so this hot water is being used for bathing, let's say, very hot water is coming. Very hot water is coming means that is actually burning our body, that is falling on our body through shower, and that is burning on our body. But we cannot control it because there is no control on the steam control valve. Once it is opened, it is opened. It will always be giving the steam inlet to the water. So this is actually called a open loop water heating process. What is the problem? Problem might be the water might get too hot, or it might not get heated properly. So though there is a temperature sensor, but this temperature sensor output we are not using anywhere. Just check in the previous case. This water level sensor output should go and it should control the tap. Then only we can say it is feedback. If you are just taking the water level sensor output and not connecting it to the tap, then it is not a closed loop system. So here the same thing is happening. We are measuring the temperature, but we are not using this measured value for anything. Actually, this measured temperature should be able to open or close the steam control valve through an actuator. If we can do that, then only it is going to be a closed loop system. So in this case, though there is a temperature sensor which is given by TL, T stands for temperature, L stands for liquid, TA stands for ambient temperature, B stands for the outlet, A stands for the inlet pipe cross section, B is the outlet pipe cross section, QB, Q stands for flow, okay, volume per second. So QB is the outlet flow, QA is the inlet flow, TO is the water temperature, all those things. So these are called process parameters. So in this case, though we are measuring the temperature, but we are not using this temperature for doing anything. We're just measuring it. Okay, temperature body का ज़्यादा है, but तुम medicine नहीं ले रहे हो. That means it's not a closed loop system. Temperature ज़्यादा है, then you are taking medicine. Then that measured temperature is having some meaning. Otherwise, just temperature ज़्यादा है and you are not taking medicine. So that's open loop system. So only measurement is not a closed loop system. when the measured value is used to actuate the control process, then only it's a closed loop system. So in this case, there are, I think the process is understood. So in this case, there are 3-4 things that we will see. First thing is, what is the controlled parameter? So what is the main controlled parameter? Though we are not controlling it here, but when we will see the same process with closed loop, okay, we will convert this open loop process again into closed loop process. We will find what is controlled parameter. So controlled parameter in that case will be water temperature. So we can control that by proper controller and all. Okay, so controlled parameter would be in that case water temperature. And who can be the main controlling parameter? Main controlling parameter can be steam inlet. How much steam you are inputting and what is the temperature of the steam. Here two things are given, check QS and TS. So QS is how much steam you are inputting to the metal pipe, and TS is how much is the temperature of that steam, okay, with which you are trying to heat up this water. So these two things are called as main controlling parameter. Controlling what? Controlling the temperature of the water bath. Okay, so one is controlled parameter and one is main controlling parameter. And what is the control element? Main control element is the steam control valve. So why this process is called as open loop? Because in this case, the measured value is not connected to the main control element. In this case, the measured value, that is the water temperature, TS, a steam control valve to some actuator. Hence, it's a open loop water heating process. What is the downside? Downside is whatever water is taken out and from the shower, it is falling on our body. If the water temperature is too high, we cannot use that water because it is too hot. We cannot bath there. And if the water temperature is too cold, it is not heated up properly, then also we cannot take bath. So our main purpose of putting a water heater for taking bath is not served. How can I improve this process? So how can I improve this process is by a closed loop water heating process. So in the exam, we will be asking you, give the example. So better you give this example because this is much more of a complex process and you can explain the necessity of a controller or necessity of a control valve. Here it is given better in this case. So the same process, what all things I am doing now. So here there is no electronics. Now here there are a lot of electronics here. Same process, but I am putting a controller. Okay, so I am putting a microcontroller here. Microcontroller will take the input. So what is the input? So whatever is the measured temperature output, that is given to the microcontroller. Microcontroller is given another input set point. Let's say I want the water temperature to be 70 degrees centigrade. Maybe not for bathing, but for some purpose. I want the set point or water temperature inside the bath to be 70 degrees centigrade. So that's why this is called a set point. But this can also be called as a command input, which is coming to the controller. Now controller will compare these two. Controller will compare how much is the water temperature now, which is measured by the TL or temperature sensor. Okay, it is suppose 60 degree. And what is the set point? Set point is 70 degree. That means the required temperature is 10 degree less. So the controller will take the decision. So there is a comparator. So comparator can be a op-amp based circuit. You have studied op-amp in first year. So there is a comparator circuit. So this input from the sensor and the set point, these two things are compared. And after comparison, the controller comes to know that yes, the input or water temperature is less. Controller will give signal to the control valve or the valve, steam control valve, that you keep yourself opened because water temperature inside the bath is still not reached the set point temperature of 70 degrees. I'll repeat the process again, that here this is the temperature TL and this is continuous measurement of water temperature. Let's say this is 60 degree and we have defined that we want this water degree. That means now the water is not that highly heated, it is still 10 degree less. Controller compares the set point as well as the measured value, and whatever is the difference, that is called as error signal. As long as the measured value is not equal to set point, that means error signal is there. As long as error signal is there, this controller will give a feedback to the control valve, that is temperature of the water is not sufficiently high, whatever is the required value of 70 degree, it is still less by 10 degree, so you please be on. So control valve will remain on and the process will go on. So steam will come inside the water and this water thing will get heated up, and then eventually this TL will become 70 degree. So the comparison in measured value and set point value will continuously go on inside the controller, which is can be a microcontroller. And as soon as the water temperature becomes equal to 70 degree, the controller output will tell the control valve, yes, now the water temperature is 70 degree, you please close yourself. So in that case, control valve will close itself. So this signal will help the actuator. Actuator will close the control valve and no more steam flow will occur inside this pipe. So temperature in the water is now 70 degree. The process is reached. The process, whatever requirement was there, it is reached. But the problem is, will you stop there? Okay, the same example I can give AC. As soon as we enter the hot room, we turn the AC on and we set it to 22 degrees centigrade. So currently room temperature is 30. Water room temperature keeps on falling because there is a sensor on the body of AC itself. There is a temperature sensor. It is sensing how much is the room temperature. So we have set 22 degree, that is nothing but set point, and continuously there is a temperature sensor which is sensing how much is the room temperature. So room temperature is 30, then cooling occurs 28, then cooling occurs 26. Continuously the comparison is happening between the set point of 22 degree and room temperature of 30, 28, 26, 24. And as soon as the room temperature comes to 22 degree, at that time controller tells the compressor inside the AC that okay, room temperature has now become 22 degrees centigrade, you take rest. You cannot switch off the AC because after some time again room temperature will start rising. Again at that time we have to turn on the compressor and again we have to start cooling the room. The same thing happens here also. So initially this temperature was less than 70. Now after certain time it has reached 70 and the controller is telling the control valve, okay, you be off, shut off. So now the set point has shutted off the control valve. Control valve is not allowing any steam inside the water. Water is now 70 degree. But as time goes, the water will cool down. Okay, so it will again keep on falling, 68, 67, 66. Again that measurement will come to the controller and again controller will start telling through the actuator, it will tell the control valve that yes, water temperature is falling. Again you insert some kind of steam through the pipe. So this thing goes on. So this is the whole process, and this is actually a closed loop. Same thing, what is the difference between open loop and closed loop? In open loop we don't have any control over the control process. So in open loop, whatever may be the temperature of the water, we don't know. It can be 100 degree, it can be 30 degree, we don't have any control over that. Okay, but always as a human being we want the process to be automated. We want to have the whole control in our hand. So we want the temperature to be 70 degrees centigrade because I'm comfortable taking bath in 70 degrees centigrade. So I will set the set point first. So there will be a switch in the microcontroller. I will just press 70 button. And now we are doing projects. So through IoT, we can set the set point through IoT or through mobile phone. Okay. So this whole thing can be controlled by IoT, and IoT control is there in the mobile phone. So before I'm entering the toilet bathroom, what we do is we set the temperature of the water of the geyser to be 70 degrees centigrade. So before 5 minutes of taking bath, I will set the temperature as 70 degrees centigrade. As soon as the water reaches to 70 degrees centigrade, I will receive a message from this water heating system that okay, yes, on mobile itself I will get the message. So this can be a good project. Okay, and this is a closed loop system by using IoT. So it will tell that yes, now your water is 70 degrees centigrade. You can now go to the bathroom and you can take bath. Likewise. Okay, so this is closed loop process, but only thing is it is little bit more complex because here we are putting controller, controller output. Here we need an actuator, and that is actually a control valve. So some amount of electronics is involved in the closed loop process. Whereas open loop process is very simple, but open loop process we don't have proper control over open loop process. Open loop process is not a automated process. That is the biggest downside. Closed loop process is a automated process. So I think in exam, these two processes you can explain if open loop and closed loop things are asked. Let us see now some very basic block diagrams of open loop and closed loop process. I'll go very fast because I told you the processes. Now I'm coming back to the basic block diagram. So this is a command input at set point. We are talking about open loop process again. This is a controller. Okay, so controller is not there, but we are just saying a controller. The controller is of no use. Okay, so there is a controller, but it's not getting any feedback. Okay, it's not getting any feedback means it cannot take any corrective action. So it is there. Valve is there. Valve is the controller, but the valve is not being controlled properly. Controller is there. Okay, but the controller is not being controlled, or quality of the output is not enhanced. There is a steam valve. There is the controller, but you are not getting the proper feedback from the output. The temperature is very high or temperature is very low. You either close yourself or open yourself. All those things are not coming. So though there is a controller brain, but the brain is not getting any feedback. So whatever is the output, controlled output, it is not controlled up to the expectation level. And whatever is the output of controller, so this is a technical term, manipulated variable. Okay, so manipulated variable is nothing but the whatever is the so there's a controlled output is the water, and manipulated variable is whatever is the controller output. Why controller is required? Okay, so I'm teaching you, you are understanding. So I am the controller, you are the student, you are the process, you are gaining knowledge. Now there are certain disturbances. What is the disturbance? Maybe suddenly your friend is calling, chalo, let's go and play. Okay, yeah, some of your friend might be calling, okay, let's go and watch a movie, all those things. So continuously the process will be under some external disturbance. Whenever we are controlling the room temperature very properly and all, it is controlled. Suddenly what happens, there is a huge heat wave in the outside that will suddenly change the process dynamics. So if there is sudden impulsive or some kind of process disturbance, that actually will change the whole process dynamics, and that will actually come at the output, and that will affect the controlled output. So certain times if we see the so this is actually a open loop control system. What is disturbance? So you can see this. This is actually a closed loop control system. Here you can find there's a command input or set point. I told you this is 70 degree. This is coming to the controller. The controller is giving some output to the process. What is the process? That is the steam flowing through the liquid. And at the output, there is a here there is a sensor. There is a temperature sensor. That temperature sensor is sensing how much is the fluid temperature at any time, and that is feeding back to the controller. So controller is measuring how much is the set point, 70 degree, how much is the fluid temperature, 60 degree. So controller will understand that yes, output temperature has not attained the actual set point value of 70 degree. So what will controller do? Controller will generate a signal that is called manipulated variable and tell the actuator that you please keep the steam valve open, because till yet the process temperature, required temperature of 70 degree is not achieved. Okay, so as long as this output temperature is not going to 70 degree, this feedback signal will keep the controller always on hunt, and the controller will keep on telling the process, you please keep on heating the water. That is what. Suddenly what happens outside, what is disturbance? So this is very important thing. Why we need control? Control is required because continuously the process is under some kind of disturbance. So the process was going on, the temperature is kept at 70 degree, no problem. Water temperature is maintained 70 degree by a closed loop control system. By the way, this is called feedback control system. This is called closed loop control system, and this is called the analog feedback closed loop control system. So if they are asking analog control system, if they are asking closed loop control system, or if it is asked feedback control system, what diagram is to be drawn in the theory exam, I will show you in the next slide. So this is the diagram that you have to show in the exam for analog control system or closed loop control system or feedback control system. So what is there? Again, you find the same thing. This is the control logic, or this is the controller. Okay, and this is the process. This is the process space. This is the water bath. And between control and process, there is the actuator. So I told you that actuator is nothing but a solenoid. Okay, and this temperature we are tracking, that this temperature should be 70 degree. So in the feedback element, as shown in the previous case, measurements on output. So feedback path, what is there in the feedback path? You can write it down in your notebook that in the feedback path there is a sensor. So feedback path is always having a sensor, and that thing is actually sensing how much is the water current temperature and feeding back to the control logic. And control logic is actually comparing what is the set point input, what is called as reference input or command input, and the feedback. So these two things are compared in this S, which is called as a summing junction, or which is called as a error differential kind of thing, or this is an error amplifier. Okay, so this S is called as a summing junction, where you can see this is negative. So there are two kinds of feedback possible. One is called as negative feedback, and this is called as positive feedback. So in this case, mainly we are using negative feedback. And here there is the reference input or command input of 70 degree. Now this is 70 degree, output is 60 degree. So a 10 degree actuating error signal is equivalent to 10 degree. That will go to the control logic. And it is plus 10 degree. Plus 10 degree means output temperature is less. That is, the controller will understand that feedback signal is 60, input signal is 70, output is 10 degree less. It will tell the actuator. Actuator is a solenoid valve that you keep yourself open and keep the steam valve open so that the heating process will go on. Now this process goes on for many times, and the output is now 70 degree. Error signal is 0, actuating error signal is 0, control signal is kind of 0, actuator element is shut off, and temperature is 70 degree. Suddenly what happens is somebody comes from the outside and put some very cold water inside the bucket. Okay, so this is, I'm explaining now what is meant by disturbance input. Something happens that temperature is attained 70 degree. We are very happy that okay, temperature of the water is now 70 degree. Suddenly somebody comes from outside and puts some very cold water inside the process. That's external disturbance. That is uncalled for. You did not expect it. And as soon as huge amount of energy, so cold water is also a type of energy. So, okay, so that's a disturbance. As soon as disturbance is given to the system, suddenly what you will find is temperature will fall in one shot. The temperature will fall to 50 degrees centigrade. Okay, so you are allowing, so this is the downside of closed loop system. That is, disturbance affects the output and the output deviates from the actual command input or set point. So this is a downside of feedback control system. That is, initially the output temperature is less, controller brings it to the set point of 70 degree, process is going on properly, no problem. Suddenly some disturbance occurs, and the disturbance actually occurs and changes the output. So disturbance actually is reflected at the output. So this is a very bad thing. Okay, so disturbance is reflected at the output, then immediately controller cannot bring it to 70 degree. There is some process loop. So somebody just comes and pours some cold water inside the bucket, which was at set point. So suddenly the temperature drops to 50 degree. Now 50 degree is the measured temperature. This input is 70 degree. Actuating error signal will now become 20 degree, 70 minus 50. Controller comes to know that there is a huge deviation in the output of the temperature. So controller will tell the actuator that you please keep the valve open, and valve will be entering a lot of steam inside the process. So temperature from 50, it will become 55. Again, the 55 is fade back, but it is 70 set point. So the error signal reduces. Initially, the error signal was 20. Now the error signal reduces to 15 dB. It tells the control logic. Control logic tells the actuator, you keep yourself open. And this temperature now becomes 60 degree. Likewise, this is called control loop, and this is called control lag. That when the error happened and when again it comes back to 70 degree. This difference of time is called as control lag. And control lag does not contain one loop. After 3, 4, 5 iterative loop, so from 50 degree directly the temperature will not come to 70 degree because the process is a slow process. This is the problem of feedback control system. It's a slow process. So from 50 it will increase to 52, then 54, then 55, 56, 57. So maybe after 15 minutes again this output temperature will come to 70 degree. So it will come to 70 degree, sure, because it's a feedback process, but it will take some time. Okay, so there are two downside of feedback control. First downside is the feedback control allows the disturbance to come to the output. So initially it was 70 set, but suddenly some disturbance occurs, and the disturbance will come at the output and reflect at the output. That is a bad thing. Okay, so first downside of feedback control is the problem or disturbance will reflect at the output, and then we will start correcting it. Okay, and correction also does not happen immediately. Correction will take some 3, 4, 5 iterative loop, and after 3, 4, 5 iterative loop, the feedback will make the temperature again to the set point. So these are the two downsides. If you want, you can write down. First is disturbance is reflected at the output side, and the control parameter gets damaged. Okay, so the control process actually gets damaged, and controlled output is not a controlled output. Control output deviates from the actual value. That is the first thing. Second thing, it takes some time. So whenever there is a damage, whenever the controlled output deviates, there is a time lag. Immediately it does not come back to the set point. It takes quite a lot of time, 3, 4, 5, 6 iterative loop to come to the set value again. So there is a time lag in the feedback control system, and the disturbance is reflected at the output. So these are the two problem of feedback control system. So this is a diagram of feedback control system. This is the diagram of closed loop control system, and this is the diagram of analog control systems. Okay, all these three you can explain with respect to this diagram. And what is the main problem? Main causing problem is disturbance. So the process can very easily come to set point and stay there, but as long as there is some disturbance occurring to the process, okay, then the job of the controller is to reduce the effect of those disturbances and bring the process again to set point value. This is what the feedback control is doing. Okay, now here is the input output configuration of open loop control. Here is the example of open loop control. So this is the valve of steam flow. The steam is coming, and it is coming inside the room radiator and keeping the room temperature high. Okay, but how much high, I don't know. If the too high room temperature, then there is no automatic process to control it. Okay, so this is the downside of the open loop control. This is a basic closed loop control block diagram. But if in the exam they ask, you don't draw the previous one because it does not have actuating error signal, it does not have the error amplifier. So this is a very basic thing for basic understanding. If they are asking feedback control or closed loop control or analog control system, everything inside this block diagram you have to explain in the exam. So there are two things you can explain. One are the block diagrams. What are the blocks? So this is a controller, this is the actuator. Actuator is nothing but a solenoid valve or kind of a thing which converts the electrical control signal into mechanical movement, and that will actually open or close the valves. Depending on opening or closing of the valve, the control system parameter will be controlled. And whether we have reached the set point or not, that is measured by a sensor which is kept in the process, and that will give a signal back by the feedback element, and this signal or that feedback signal will come to the summing junction, and summing junction there are two things connected. One is a set point and another is the feedback. If the difference in set point and feedback is high, control logic will generate high control signal, and if the difference between set point and feedback signal is less or zero, then control logic will tell the actuator we are almost close to the controlled parameter value, so you do less control or you just stay there as it is. Okay, but if you are staying there, then also the temperature will not be stable at 70. It will fall because the water will get cold. As soon as it falls beyond a certain limit, again the controller will start and the process will be kept in the set point. So far we have discussed four things. Okay, first is we have discussed what is open loop control, what is the downside, what is the advantage, what is closed loop control, what is the advancement of closed loop control compared to the open loop control. Okay, it is adding to the automation. Then we have seen analog control, then we have seen feedback control. And feedback control is actually two types: positive feedback control, negative feedback control. Negative feedback control, so you can write down in your book, negative feedback control reduces the overall system gain. So it's a very important point. You write down in your notebook because you will not remember, and this might be a IEA short question. Negative feedback control reduces the system gain, and if the system gain reduces, system stability increases. So this is three formulas, three mantra I had given you last day. Okay, so if there is more energy in the system, system is unstable. If there is less energy in the system, system is stable. Okay, so negative feedback control actually reduces the system gain, and if the system gain reduces, means system stability will increase. So this is a very important thing. Through the feedback control, we can increase the stability of the system. But which type of feedback control? Negative feedback control. Positive feedback control increases the system gain, that reduces the stability. So these are two things you write down. Negative feedback reduces the gain, increases the stability, and positive feedback increases the gain and reduces the stability. So question is asked, if you want more stability of the system, which type of feedback will you use? To increase the stability of the system, which type of feedback will you use? Answer is negative feedback. And to increase the gain of the system, which type of feedback will you use? Positive feedback. So to increase stability, we will use negative feedback. To increase gain, we will use positive feedback. So analog control system, closed loop control system, feedback control system, negative type mainly. The same block diagram you have to explain. So this is the feature of closed loop control system. When disturbance enters the process, so you can explain from here. Controlled variable output deviates from set point. So there's a controlled output. So disturbance is coming. Controlled output deviates from the set point. So I told you 70 degrees the temperature. Suddenly somebody puts some cold water into it. Temperature deviates. It is fed back to the S. S is nothing but the error input. So whenever this thing is happening, this signal is fed back to the error amplifier. It generates the difference between a reference, that is a set point, and the actual controller output. So this error signal is the actuating error signal, which manipulates the process through the control logic, and the process gets changed accordingly. So depending on the control logic, depending on the actuator signal, the signal is given to the process, and process will now change its value so that this output reaches to 70 degree. In that case, the error will reduce and the process will stabilize. This is the whole feedback control system process. Lastly, so this is, I think, the last slide for today. Another important controller I'm going to explain to you, which is called as feed forward controller. So I told you there are two problems in the feedback control. First one is the disturbance affects the output, and second one is it takes quite a lot of time to correct the output and bring it back to the set point value. What does feed forward control do? I will explain by means of an example. Feed forward control does not allow the disturbance to come at the output. Before that, feed forward control takes action. The example is in winter, we know that the water being used for bathing would be very cold. So this is a priori knowledge. So this is a feedback controller. A priori system knowledge drives the controller. So whatever we already know, okay, what do we know in the winter time? That the water is going to be very cold. So you don't allow the water to fall on your body. You sense it and then you start the geyser. That is actually feedback control. That is bad. What is feedback control? Let the disturbance disturb the process variable. So let the cold water fall on your body. You are getting. What is feed forward control? Feed forward control does not allow the cold water to fall on your body and get the chill, because chill somebody might catch cold. Feed forward control is driven by a priori knowledge which is occurring every time. Why do you carry umbrella in the month of June, even if it's not raining? Because it's month of June, I know there might be rain, I'm carrying an umbrella. So there is a priori knowledge, or there is some kind of forecasting. Okay, I know the water is going to be cold in winter, so before entering the bathroom, before 5 minutes, I will start the geyser. So this is a flow controller. This flow controller will start the steam valve before 5 minutes, and water cold fluid is coming in, but this flow controller is going to control the steam flow through this exchanger. So there's a heat exchanger. Heat exchanger means whatever steam is coming, the steam is will be flowing through this, and this water pipe is surrounded by the steam. So in heat exchanger, which is kind of metallic pipes, okay, the steam will give all the heat to the cold water, and hot water will be coming at the output. And how much is the hot water? That is actually sensed, temperature sensor. and here there is a temperature set point. So I know that I want 70 degrees centigrade for bathing. Okay, and I am measuring how much is the temperature. But this control is not being done after I am entering the bathroom. No, this control, opening or closing of the valve, in this case, it is happening 5 minutes before I enter the bathroom. So whatever is, so this is feedback control. Before the effect or before the disturbance is affecting the output, we are taking the action. I'll give a very simple example. One student is there, and listen it carefully. I'm explaining feed forward and feedback difference. One student is there, and he is not studying. Okay, so as a teacher, I don't tell him anything. I know he is going to fail in the subject. So he fails. After 6 months of study, he fails. And he comes and tells me, sir, I have failed. Okay, so there is a feedback he gives me, sir, I have failed. Then as a controller, so I am the control, he is the process. Then I teach him and he passes. Okay, so this is a feedback process. Okay, as a controller, as a teacher, I was teaching him continuously in the semester. Okay, but he did not study, he failed. I knew he is going to fail, but I don't tell him anything. Okay, a priori knowledge is there in my mind because the student was not attending lecture, his writing was very poor and all those things, but I did not tell him anything. I just allowed the process the way it is going. Okay, the student failed. He came back and he told me that, sir, I have failed, feedback, and then I take the control action. This is called feedback control. What is feed forward control? I just check the students' IE result. I check the student's performance in 1 or 2 classes, and I tell him a priori. A priori means pehle se. Okay, I forecast that dekho, you are going to fail. I did not take the feedback. Feedback happens after the end-sem exam. I did not take the feedback. I told him a priori, pehle se, because I am a very smart controller. So feed forward controller is a very smart controller. So I tell him a priori that you are going to fail. That student listens to me seriously and he studies and he passes the exam in the same semester. So previously I allowed the disturbance, that his disturbance, to affect his study. He failed. Then I taught him. After 6 months I wasted and then he passed. That is feedback process. Purpose achieved. But what is the main problem? It wasted 6 months. What is feed forward control? Just looking at the process little bit. The controller is a smart controller. It will tell that you are going to fail. Because I have checked your IA paper, I have checked your performance, you're going to fail. I give him the tips, I forecast it, and he listens to me. He studies, he passes in the same semester. So the same example I have given here. In winter, we know that water is going to be cold. So we turn on the heater 5 minutes before taking bath. Water gets heated up, the hot water is used for bath, so we don't get the chill. The a priori knowledge that the water in winter will be cold, we heat it up before use. This is actually feed forward control. It is also called as an anticipatory control. Why anticipatory? Because we know that water is going to be cold. We are anticipating it, so we are heating it up before use. Okay, so this is anticipatory control, or D-type control. You don't know D-type, this is called derivative type of control, and this is with forecasting. A priori knowledge. Feed forward is control is using forecasting. What is the forecasting? Bhai, pani thanda hoga, pani garam karo and then use karo. This is what is called as feed forward control. Very smart kind of control. The forecasting is based on the previous knowledge. What is feedback control? Feedback control, the cold water first falls on our body. Okay, the disturbance affects the process, output is deviated, we get a chill, and then we turn on the heater. And it takes some time for the heater to heat the water. So two drawbacks are there for feedback control. First is the bad effect of external disturbance reach to the system. That means first the cold water is falling on our body, we are getting a chilled, we might get cold or fever. So the damage is done first and then control. This is what is feedback control. Damage is done because what we are finding is the disturbance is affecting the output. Damage is done. Student fail ho gaya. 6 महीने बाद फिर पास होगा. Okay, that is actually feedback control. But what is feed forward control? I don't let him fail. शुरू से ही, just looking at his performance for 1 or 2 months, I give him a warning. I give him a control signal that you are going to fail. Please start studying. Okay. So the feedback control, it actually allows the output to deviate, and then the control action starts. Feed forward control, before the output deviates, it starts the controlling action. Second drawback of feedback control, when the control action starts, the student fail ho gaya, and after that 6 months goes, so there is some time lapse. Control action chal raha hai, chal raha hai, chal raha hai, and after 6 months he passes. So from the time the control action starts till the corrective action is completed, okay, there is some time elapses, and that time elapse might have adverse effect on the whole process. Feedback control does not have such problems. So this slide is for feed forward control. What are its advantages? It is anticipatory. पहले से ही उसको समझ में आता है. It is based on a priori knowledge and all those things. This is a forecasting type of a anticipatory type of a controller. This is a smart controller. Whereas feedback control is a traditional controller. It wastes some time. Here control action happens, but after it gets disturbed. Biggest line, you can write down the last line for this lecture. Feed forward control does not allow the disturbance to affect the output. Before that, feed forward control takes the action. So feed forward control does not allow the disturbance to affect the output. Before the disturbance affects the output, feed forward control takes action. Feedback control allows the disturbance to affect the output. It damages the output. Then the feedback action takes place, and it takes quite a lot of time, few loops, for the feedback control to bring the output again to the previous level. These two are the main differences of feedback control and feed forward control. Next lecture, tomorrow, we will start with digital control and its block diagram. Thank you.